Good afternoon. In today's class, we will be seeing the continuation of your TCP, that is Transmission Control Protocol. So basically, TCP connection, as we have established that TCP is connection oriented. So TCP, we can say that it is connection oriented. And what do you mean by connection oriented protocol? It establishes a virtual path. So this connection oriented protocol will have a virtual path between source and destination. It will have a virtual path between the source and destination. All the segments belonging to a message are then sent over this virtual path. So suppose if we have a message, and for that message we may have multiple segments, then these segments are sent over the virtual path. Now, using a single virtual pathway for the entire message facilitates the acknowledgement process as well as retransmission of damaged or lost frames. So in the virtual pathway, we will be able to send the segments, acknowledgements. ACK is acknowledgements. Then we may even retransmit the messages which are lost. Retransmission of, there are two kinds of retransmissions. First is the damaged frames. The next is the lost frames. So these are the things we can send on this virtual path. Now, basically, you will think TCP uses, we know that TCP uses IP. Okay, TCP uses the services of IP, and IP itself is a connection-less protocol. IP itself is a connection-less protocol. Then how can TCP be connection-oriented? So this is the question mark that is being asked. Now the point is that TCP connection is virtual. So that is why we are saying it is a virtual path, not physical. And TCP operates at the higher level. So you know that the network layer is the third layer and the transport layer is the fourth layer. So TCP uses the services of IP to deliver individual segments to the receiver, but the connection is controlled by TCP, right? So if a segment is lost or damaged or corrupted, damaged or corrupted is the same thing, it is retransmitted. Unlike TCP, so TCP node knows that the segment is being retransmitted. But what about IP? IP does not know that whether it is a retransmission or we are sending a new message. Okay, so IP is unaware basically. It does not know about any of these things. If a segment arrives out of order, now what will happen if it is arriving? The segment is arriving, but it is arriving out of order. Basically, segment 2 is arriving first and segment 1 later. Then what will TCP do? TCP holds the segment until the missing segment arrives. Until missing segment arrives. So this is the functionality of TCP. What it is doing, it is retransmitting and it is also holding the segment if they are going out of order. So even this IP does not know. IP does not know how the TCP is holding or whether it is reordering. So now in the TCP connection, whenever we are talking about the TCP connection, we will require three phases. Now what are those three phases? The first is the connection establishment. Then the second is the data transfer. And third is connection termination. So first the virtual path is established, then the data is transferred, and finally the connection is terminated. So what will happen in the connection establishment? We will see that. So yes, connection establishment, we can see this with the help of a diagram. First and foremost, TCP, we know that it establishes a full duplex mode. Now, what do you mean by a full duplex mode? The data can be transmitted in both the directions. So it can be transmitted from the sender to the receiver and from the receiver to the sender. So let me just write the sender and the receiver. Yes. So S is the sender and R is the receiver. So that full duplex mode, TCP connection is in full duplex mode, and that is data is transmitted from the sender to the receiver and to and fro respectively. Now, when two TCPs in two machines are connected, they are able to send segments to each other simultaneously. So we know that the sender will send the message and the receiver will send back the acknowledgement. So this is basically both of them are able to send the messages simultaneously. This implies that each party must initialize communication and get approval from the other party before any data is transferred. So what we are saying basically is the client should start the communication and the server will respond back. Then we can say that the connection is established and we can send the data. So now this figure, which is showing the three-way handshaking. So connection establishment usually in TCP is called this three-way handshaking. It is given over here. Three-way handshaking. And this example, it is showing an application program called the client. It wants to make the connection with another application program called the server using TCP. Now, first and foremost, the process will start with the server. The server program tells its TCP. So first and foremost, it is not starting with client, it will start with server. Now, what will the server do? Server will inform its TCP. So server is telling the TCP that it is ready to accept a connection. So what will the server tell? It will say that I am ready to accept a connection. Now, yet connection has not been established. Only it is saying I am ready to establish a connection. Okay. After that, this request which it is saying that I am ready to accept is known as passive open. Okay. And although the server TCP is ready to accept any connection from any machine in the world, it cannot make the connection itself. So the server is not able to make the connection itself. It just says that I am ready. Now the client has to approach the server that I want to make a connection with you. Okay, so this is the next part. The client program issues a request. So first we have seen about, let's write the terms over here. We have seen about passive open. Okay, this is when the server is telling the TCP that it is ready to establish a connection, but the server itself cannot establish a connection by itself. Now what will the client do? The client program issues a request for an active open. So we are talking about active open here. Basically, what is an active open is a client that wishes to connect to an open server tells its TCP that it needs to be connected to that particular server. Suppose if this client needs to be connected to this server, then this server should be ready to accept the connection, which is the first part. Then the second part will be client will say to its TCP that, listen, I want to make the connection with this server. Okay. So now you can see that we can see the start of the three-way handshaking process. So first it is sending the it is requesting for the server to be connected to this. So this process is known as active open. So to show this process of three-way handshaking, we use two timelines, one at each side. Okay. So each segment has values for its headers fields and for some options fields too. So we have seen the TCP header in the previous class. Now we will be seeing the use of that header over here. So, but we are only showing the few fields necessary to understand the space over here. We show the sequence number, the acknowledgement number. So this is the sequence number, the acknowledgement number, the control. Here we have clearly the sequence number, the acknowledgement number, and these are the control flags and the window size if not empty. Okay. So the three steps in this phase are, so first and foremost, the client sends the first segment. So we know that whenever we are talking about transport layer, we will be saying it as a segment. So the first segment is known as the Syn segment. Now what is the Syn segment? in which only the SYN flag is set. So we know that how many flags we had in the TCP header or the TCP format. We had 6 flags. Let's just write it over here. So first were the URG flag, then ACK acknowledgement, then PSH push, then RST is reset, then SYN is the synchronized sequence numbers, and finally we have the terminate the connection, which is SIN. So first and foremost, what it will do, the client sends the first segment, a SYN segment in which only the SYN flag is set. Okay, this segment is for the synchronization of the sequence numbers. So to synchronize the sequence number, so it will say it is starting from 8000. Then the acknowledgement will be, I want the next number 8001. That is how it will synchronize it. So it consumes one sequence number, and when the data transfer starts, the sequence number is incremented by 1. So here, whenever the data transfer is starting, we will increment the sequence number by 1. We can say that this segment carries no real data, but it carries one imaginary byte. Okay, so a SYN segment cannot carry data, but it consumes this one sequence number. Now we have the server side. From the server side, what will it get the reply? So it will send the second segment, a SYN segment plus the acknowledgement segment with 2 flag bits set. So what it will do is basically it will set the acknowledgement flag and it will set the SYN flag, that is synchronization flag. Now this segment has 2 purposes. What are the 2 purposes? I will just mention here. It is a SYN segment for communication in other direction. So if we are sending, this server is sending data, the sequence number will start from 15,000, and also the acknowledgement of this packet. So our client had sent the packet with the sequence number 8000, so it will send the number 8001. That means it has received this earlier packet. So communication with the other side, and it will also send the acknowledgement. So this SYN plus acknowledgement segment also will not carry data, but it also consumes one sequence number. It is also beginning from 15,000. Now after that, the client sends the third segment. Now what will that third segment have? It is just an acknowledgement segment. It acknowledges the receipt of the second segment with the acknowledgement flag and the acknowledgement number field. So here it will say, I have received your sequence also, and I'm sending the acknowledgement 15,001. So the sequence number in this segment is the same as the this one. Why is it? Because the acknowledgement segment does not consume any sequence number. So the sequence number is same because the acknowledgement, we are just sending an acknowledgement. We are not sending any new data. So that is why the sequence number is same over here. It is just sending an acknowledgement. Now, what will happen? There is one rare scenario. So in this case, one rare scenario or rare situation is which is known by the name of simultaneous open. Now, what do you mean by this simultaneous open? When both the processes are saying they are active open, that is, both of them want to establish a connection. Then when both of them are saying active open together, then that is known as a simultaneous open. So what will happen in this case is both the TCPs will transmit SYN plus acknowledgement segment to each other. So both of them will transmit the second segment and one connection is established between them. One connection is established between them. So this is the simultaneous open, which is a rare situation when both of them are saying that we want to be active open at the same time. Now we will see a few other things with respect to this three-way handshaking. So first and foremost is SYN. that is synchronization flooding attack. Now what will happen basically is the connection establishment procedure in TCP is uh, prone to a serious security problem called this synchronization flooding attack. Now when this will happen? This will happen when a malicious attacker sends a large number of SYN segments to the server. So suppose there is an attacker which wants to attack the network, then he will send a large number of synchronized segments to the server. Okay, pretending that each of them is coming from a different client by faking the source IP address in the datagram. So what it will do is it will pretend that each segment is coming from a different client. So what will happen? The server assumes that the clients are issuing an active open, allocates the server, what it will do? It will say that okay, so the clients wants to connect with me, and it will issue an active open. That is, it will send the Syn plus act, which is the second packet of your three-way handshaking. Okay, so it will allocate the resources such as creating. So whenever this three-way handshaking or any communication will happen, the server will have to create a communication table, and it also has to set the timers. We have seen this in the case of go back and the concept of timers. Okay, and the TCP server, then it will send the Syn plus act, the second packet of your three-way handshaking, to the fake clients which are lost. Okay, so because this all of them are coming from a single person who wants to attack, these packets will get lost because there are no such clients. So during this time, however, a lot of resources are being used, because it is using all of these resources. It is creating communication tables and then setting the timers. The number of SYN segments is large, and the server eventually runs out of the resources and may crash. So what will happen? The server will crash because it is using a large number of resources. So this type of flooding attack belongs to a type of service which is known as denial of service attack. So basically, your attacker is not giving the service of various clients to the server. So this is a very important concept, which is denial of service attack, in which an attacker, what it will do, it will take the entire system with so many service requests that the system will crash and deny service to every request. So after this, what will happen? It will deny the service to every request. Okay, so some implementation of TCP have strategies to lessen the effects of this SYN attack. Some have imposed a limit on connection request. So what few TCPs have done is they have set a limit. So a limit on connection request has been set. So these are the strategies, and others filter out the datagrams coming from unwanted source address. So if your source address is not recognizable or unwanted, they won't allow the datagrams in. And one recent so actually not recent, since we are studying from the old syllabus, but one strategy we are using is actually known by the name of spookies. If you know your browser well, then you will know the spooky. That is, it postpones the resource allocation until the entire connection is set up. So it will keep on postponing it until you have the connection completely set up, and for that we use this cookie. And also we have this new transport layer protocol that is being used these days, which is SCTP. Okay, so this is with respect to the Syn flooding attack. So before going any further, we will see the few things important with three-way handshaking. So first is SYN segment, or the synchronization segment, cannot carry data, but it will consume one sequence number. We have seen that already. Now we will have the next one. A synchronization plus acknowledgement segment cannot carry data but does consume. It also does not carry data but will consume one sequence number. An acknowledgement segment, if it is carrying no data, consumes no segment, consumes no sequence number. So we have seen that the sequence number was same in both the cases. So that is with respect to the first and the third scenario, the sequence number was same. As you can see, that is acknowledgement segment is not consuming any sequence number. Now we will see the concept of data transfer. So after the connection is established, we know that data has to be transferred. So bidirectional data transfer can take place. We know it is in full duplex mode. So two direction, the data will be transferred in both the direction. The client and server can both send the data and acknowledgement. So this is important. In the case of TCP, both client and server can send the data and acknowledgement also. Now we will study the rules that we are seeing. So for in this example, after the connection is established, the client sends 2000 bytes of data in two segments. So we will see that here client is sending the data from 8000 to 10,000. So it is first sending 8001 to 9000 and then 9001 to 10,000. The server is then sending 2000 bytes in one segment, and the client sends one more. The client sends one more segment. What will that segment have? The first three segments carry both data and acknowledgement. So as you can see, this is data, data, data. That is three segments of data. Two the client is sending, one the server is sending, and also you can see the acknowledgement. So this is the continuation of your earlier diagram. We know that it has sent the acknowledgement of 15,001, and now it is sending the data from 8001 to 9000. Here 9001 to 10,000. It is sending the acknowledgement for the second one. Now what will happen? This last segment, what is this? The last segment carries only an acknowledgement. So you can see it is the acknowledgement for this data, and because there are no more data to be sent. So you can note the values of the sequence and acknowledgement numbers. So sequence here 8001, the data is from 9000 till 9000, then the next sequence will be 9001. You can see the same and verify. Now the data segment sent by the client have push value flag set. So you can see it is setting a push value flag, this one, so that the server TCP knows to deliver data to the server process as soon as they are received. Now the segments from the server, on the other hand, you will see that it does not have the push flag, because mostly the server side does not have an option to set or not set this flag. Now what is about the pushing data? Now we saw that the sending TCP uses a buffer. So we have seen the buffers yesterday with respect to the sender and the receiver to store the stream of data coming from the sending application program. The sending TCP can select the segment size. The receiving TCP also buffer the data when they arrive. So this is with respect to the pushing the data where you set this flag. Now one more field we have seen is the urgent data, URG. So in this case, the data are presented from the application program to TCP as a stream of bytes. And suppose an application program needs to send the urgent bytes. This means that the sending application program wants a piece of data to be read out of order by the receiving. So if we are sending an urgent byte, means we are stopping the other data which is being sent, and we just want to send this urgent data to the server. Then what will happen is basically it will abort the command over here and it will send the urgent data. So the solution here is to send a segment with the urgent bit set. The sending application program tells the sending TCP that the data that the piece of data is urgent. So the sending TCP, what it will do, it will create a segment, insert the urgent data at the beginning of the segment, and the rest of the segment can contain the normal data also. So this is with respect to the urgent flag that we are seeing. So this is not this does not usually come. The most important here is the three-way handshaking and what are the steps in the TCP connection. Now last we will go, so we have seen the three-way handshaking while connection establishment, then the data transfer. Now we will proceed with the connection termination using three-way handshaking. So any of the two parties involved in exchanging the data, either now with respect to the termination connection termination, either the client or the server can close the connection. So usually it is initiated by the client. So most implementations allow two options for connection termination. So there are two options. First is the three-way handshaking. And the next is the four-way handshaking with a close option. Now first, what will happen in the case of three-way handshaking? So this is the three-way handshaking procedure. So in a normal situation, the client TCP, after receiving a close command from the client process, it will send the first segment and it will set the flag to FIN, which is the finish or terminate the request flag is set. Note that the finish segment can also include the last bits of data to be sent by the client, or it can be just a control segment as shown. Okay, if it is only a control segment which does not have any data, then it will consume one sequence number. Now what will happen at this is with respect to active flows. Now the server side, what will happen is the server TCP, after receiving the FIN segment or the flag, informs its process of the situation and sends the finish plus acknowledgement segment to confirm the finish segment from or termination connection from the client, and at the same time to announce the closing of the connection in the other direction also. So this segment can also contain any last remaining data, or if it does not carry any data, it consumes one sequence number, as you can see, x plus 1. Now finally, what will the client do? The client will send the last segment, an acknowledgement segment, to confirm that it has received this connection termination from the server also. And this segment contains the acknowledgement number, which is, so for this it will have the acknowledgement number plus the sequence number received. So whatever sequence number it has received over here, it will add it. And this segment will not carry data and it does not have any sequence number also. So as you can see, it will not carry, it has the same sequence number and it is not carrying data also. Now this four-way handshaking with closed option, or the with half close option, actually, just let me correct it, with half close. With half close option, you can refer to it from the textbook. It is similar to what we are seeing over here. The only difference is that either one of them will say that I want to close, so the data segments from the server to the client may be closed, or vice versa, and the other party may keep on sending the data unless it has completed. So this is with respect to the TCP connection establishment, data transfer, and TCP connection termination. Now, the last topic that is remaining in unit 4 is the quality of service techniques with respect to transport layer, and also we will see a bit of flow control and error control in TCP. So with this, I'll conclude the unit today, and maybe in the next class we will complete the unit.